everybody, and welcome back to this new episode on software archaeology. Today, we are covering some leftovers of our previous episode around 4.2 BSD and the first official TCP software stack release from 1983. We are trying to communicate 4.2 BSD not only within the limits of a small local area network, but rather than that we are trying to connect 4.2 BSD with the outside world, with servers running on the internet nowadays. We we will try also delivering some email to a real mailbox, to existing mailbox, and of course we are also covering a different network protocol that was quite popular back in the 80s, that was UUCP. And last but not least, AI, artificial intelligence, it's not only a hot topic today. It was also a buzzword or a hot topic in the 80s, where when even especially tailored computers were built for AI. So 4.2 BSD included a Berkeley implementation of the Lisp language and few others funny applications we are seeing today. But without any further ado, let's go to the command line and let's boot up the system. On the upper side window I have a host called Foreigner, and in the downside I have another one called Shul. These are the two hosts, and let me show you. This is our configuration today. We are using CMake to actually simulate or emulate a VAX 11/7080 to run 4.2 BSD. Sorry, those two hosts are in my local area network, and we are using a gateway to get those machines communicated with the internet. That's the basic setup for this experience. So let's start by taking a look at what was UUCP. UUCP was a protocol developed at Bell Labs in the mid-70s, that it was quite simple. It was simply a queue of files that were stored and forward from computer to computer within a network. We can see here a geographic diagram of the network at some point near 1983, because UUCP was the basic infrastructure to build what was to build the Usenet network. Usenet can be considered as one of the first social networks ever, and it was a bunch of news group where users can share knowledge and discuss uh, freely on many different subjects. So let's try. Here we have a simple file, simple text file. We will try to use UUCP to simply copy that file to the other host. Sorry. This is the host name, and this is the directory. Let's take a look at the time. Because UUCP, as I was mentioning, it is an store and forward protocol. Back in the day, it was leveraged using dial-out and dial-in telephone lines with modem analogic modems, and now in this setup, thanks to the help of the CMH community, I was able to set up UUCP over TCP/IP. Right, we are using UUCP over TCP/IP just to avoid hooking up those modems and all that stuff. Let me see, where was the cron tab? You see here I set up this this entry on the cron tab in order to UUCP to synchronize every 5 minutes. We can see some logs. And probably we need to wait a few more minutes. We could have also because UUCP, it also allowed not only to share files but also to send mails. So we can try sending an email sent via UUCP, and we are going to send it to our host called Shul and to the user called Redux. Well, those are my typos, and here it says that it should put that email in the queue to delivered. I think few minutes ago there was, you can see here, UUCP synchronized, and it should have copied that file to the host name Shul, and here we have the file. You see our clocks are not synchronized, but it's the same file we had on the other host, right? I'm afraid we will have to wait a little bit for that email to delivered, so I'll pause the recording for a minute and I'll be back. Well, now that few minutes have passed and UUCP synchronized, we can see the logo saying here this was the file, and here most probably was our mail. So let's see in the target host name, and it's saying that the user Redux have an email, and here we have the mail we had sent through UUCP. As I said, this protocol was the basic infrastructure for the Usenet network, at least for some years until the mid-80s. I think the protocol was replaced by another one that was an NTP. Well, we can try something probably fun, a little bit more funny. Let's see. We'll try. Oops. Well, sorry, with all of my typos, I'm trying to send this email. You see here, I'm putting here a prefix just before the real recipient of the email, that it's saying to our send mail server running on 4.2 BSD, forward this email through this other mail server that it's in our case a smart relay, a server that it's running on my host here in my Debian. It's running a postfix mail server that actually relays the email to Gmail, and then it can deliver to any current email box. So let's take a look to see if we got that email. There was an error here. My goodness, this is the error. I put the wrong relay server. should be called, I think, open at gmail.com. Well, with all of my typos again. Let's see. Now the mail was delivered through the postfix relay. So let's take a look at Gmail. Voila, and here we have it. The mail was delivered by handing it over through that smart relay server. Something I forgot to mention when we talked about the UUCP mail is that when we send, or the UUCP mail addresses was in fact a routing address. That means that within the address we set a full route that the email should follow, the message should follow. So if, for instance, if I wanted to send an email to that had to traverse 2 or 3 servers, I had to write something like this: foo bar baz, and then the user. You see, that means that the message should be delivered to the server baz, to the user DMR, through this other intermediary mail agents. So the address was in fact a route, includes the address had the routing included. Well, something else we can do, as I previously mentioned, in 1983, when 4.2 was released, there wasn't DNS. It still hadn't been implemented. So what we can try is to, that's the reason why I put this entry here in my host file. So we can try connecting to the server by using you see we connected to the FTP server from the new project. We can try to transfer this file. You see we have transferred this file. It's about 1 kilobyte. And how this works? Well, in 1983 there wasn't even or FTP client didn't have the passive mode developed. So as we are behind a NAT firewall, we are not able to use FTP without the passive mode. So what I did in order to overcome that issue is here in our host, that is in fact our gateway to the internet. We are running FTP proxy. We are running in a pretty similar way to what we've done with the mail relay server. FTP proxy allow us to get for the 2BSD communicated with the outside world by using FTP protocol. And a couple of things more we have here. We talked about Berkeley sockets. This is an example file of a C program that actually used Berkeley sockets to build a server application. So we can try to compile it, to build it. We are done. Let's try to run it. It's saying that it's listening on port 1034. This is the IP of that host, and the port was, I forgot, 1034. And you see here they got communicated. Berkeley sockets were the basic API, basic infrastructure in order to build a whole bunch of client-server applications, not only on Unix, Linux, or POSIX operating system, but also, on many others. It was we quit the application. Now we are going to try a taste of AI as it was in 1993. As you see, for the 2BSD used to come with Lisp, with a version and implementation of the Lisp programming language included. It was called France Lisp, and it was a prank referred to the Hungarian classical composer Franz Liszt. There we are just assigning a few variables and doing some arithmetics. If we want, sorry, no, that's wrong. If we want to square x to the 3 power, we've got that result. But there was also a compiler, a Lisp compiler, that was called France Liszt, just as the composer. So we are going to build an application that was developed at Berkeley. It was an implementation of the Eliza program, a program developed back in the 60s, if I'm not mistaken, in the MIT by a scientist called Joseph Weissman. So there we have built the doctor binary we executed, and now we are chatting with our beloved doctor. Back in the day, this was kind of a prototype of what was called a chatterbox, and now we used to call them simply chatbox. Chatbots, sorry. As you saw, it was a really small application, just few thousand, just 44 kilobits. But even though it was able to have some conversational, let's say, skills, you can end up having a funny conversation with the doctor. Sometimes it goes a little bit insane, or but it always has some basic sense. To some extent, the bot was able to understand some of the statements. Of course, it's not the general bot. It is supposed to be a therapist, and that's why it's a little bit tricky or limited. But with only a few thousand kilobits, it was able to at least, to some little extent, to what nowadays large language models do. But we need to highlight there's nothing large here. It's only a small single binary written in Lisp language. This implementation, I think it was written by a scientist called John Foderaro at Berkeley. And as I said, it's a re-implementation of the Eliza program developed in the artificial intelligence lab at MIT. Today is very likely we can find a version of Eliza on most of the Linux distributions out there. And here's where the Rogerian therapist simply start reflecting your own statements and hand it over back to you. For some reason, the doctor wants to keep the conversation. And that was A Taste of AI, as in 1983. Thank you.